The ancient Indus Valley civilization spanned roughly 1 million square kilometers across what is now Pakistan and northwestern India. They built highly structured urban centers laid out on precise grid systems with sophisticated drainage networks. Their physical engineering was standardized to an extreme degree, evident in the uniform dimensions of the baked bricks used across the entire territory. Trade was governed by a strict civilization-wide metrology, utilizing a binary decimal ratio system of standardized chert weights. Yet despite this massive standardized trade network, 0 coins have ever been discovered in the archaeological record. The standard historical assumption is that the empire must have relied on rudimentary barter and weighed metals to facilitate exchange. However, anthropological data from researchers like David Graeber and Michael Hudson suggests the barter-first narrative is a myth. Their research shows that institutional credit systems, ledgers of debt and deferred payment, existed long before the invention of physical coinage. This reality implies that the Indus Valley required a specific, engineered instrument to power its credit-based economy. The Indus stamp seal is the most likely candidate for this missing economic technology. These small squares of fired steatite were centrally manufactured, highly portable, and featured distinct animal motifs paired with short sign sequences. For a century, scholarship has treated these artifacts as linguistic texts or personal identifiers. The statistical and physical evidence suggests a different function, a gilt-backed, administratively issued institutional credit instrument. In its mathematical structure and physical application, the seal represents the Bronze Age equivalent of a modern credit card. Testing this hypothesis requires shifting the focus from phonetic translation to raw statistical patterns. A 2026 analysis by Krieger and Hunt examined a specific subcorpus of 179 Mohenjo-Daro unicorn seals. They looked for sequence uniqueness, the rate at which a specific string of characters appears exactly once in the dataset. This data shows that 98.3 positions 2 and 3 exhibit high variation, providing the unique account number for the bearer. Position 5 returns to a low entropy state, functioning as a terminal marker or a verification check digit. This architecture is a precise structural match for a modern credit card number, which uses a bank prefix, a unique account field, and a final check digit for point-of-sale verification. This 5-field registration model yields a combinatorial totacity of roughly 45,000 unique combinations. Mohenjo-Daro had an estimated population of 40,000. This system provided enough unique addresses to assign a specific code to every economically active entity in the city. The script's mathematical signature identifies it as a perfectly formatted registration code. A functional credit system must physically separate the instrument from the transaction record. In a spot transaction with commodity money like silver, the wealth is handed over. In a credit transaction, the buyer retains the instrument while the seller keeps a copy of the authorization. The engineering of the Indus seal solves this problem through relief-based duplication. These signs were carved in intaglio, recessed into the stone, and mirrored. Pressing the master seal into wet clay produced a positive, forward-reading impression that served as the transaction record. The mechanical parallel is exact. Before digital chips, embossed credit cards were pressed through manual imprinters to transfer numbers onto carbon paper slips. The clay tag and the carbon slip serve the same legal purpose. They document the authorized credit entry while allowing the bearer to keep the master instrument. The animal motif, such as the unicorn, functions as an issuer logo, identifying the specific merchant network. The unique sign sequence acts as the account identifier, authorizing the specific transaction. To prevent counterfeiting and fraud, the original steatite seals were fired at extremely high temperatures to become permanent, tamper-resistant, and statitite. Every physical property of the seal, its portability, its duplication method, and its durability, marks it as a tool for verifying credit. The credit hypothesis also explains why these seals are found thousands of kilometers away from the Indus Valley. Indus seals have been recovered from major Mesopotamian hubs like the city of Ur. A domestic administrative code would have no jurisdictional power in a foreign city like Ur. However, the seal functioned internationally as a credential of creditworthiness. It proved the merchant's membership in a solvent guild, guaranteeing that their obligations would be settled by the home institution. We can also interpret the rare statistical outliers in the corpus, such as the 1.7% of seals that carry duplicate inscriptions. These represent replacement issuances, new physical seals carrying the same account number after an original was lost or damaged. The dominance of the numeral 2 in the dataset further suggests a tiered membership system, with the majority of merchants holding standard class accounts. The duplicate codes, skewed numerals, and foreign find sites serve as the forensic evidence of a complex, functional credit network in active use. This leaves one final question. Why did a credit-based economy still require the rigorous standardization of chert weights? The system likely operated through a dual-layer economy. On the bottom layer, chert weights provided the unit of account, measuring the value of goods for immediate spot exchange. On the top layer, the seals authorized credit entries that were denominated in those same weight units for future settlement. The absence of large-scale written ledgers in the archaeological record is often cited as a counterargument, but most ancient South Asian records were kept on perishable materials like palm leaves and cloth, which disintegrated over time, leaving only the durable stone hardware behind. Merchants still needed to communicate these codes verbally to scribes. Through phonetic vocalization, a numeric code can be read aloud in any local language without changing the underlying data, just as a credit card number is dictated today. The Indus Valley engineered a civilization built on formatted data and institutional trust, effectively operating the world's first known information economy 7 centuries before the first coins were ever struck.